Alright YouTube, welcome back. In this episode I'm going to show you how I make custom dash panels for these golf carts. We're going to go from this busted old panel here to that. That one looks a lot better, a lot neater, and it's got all the positions there we need for all of our attachments on the dash. So this one you can see it's pretty worn out. The holes for the rivets, this one's all the way through there, the rivet's barely hanging on. That one's elongated. This nice new one we printed on the 3D printer. This can make a nice replacement. We've also made one to cover up the golf ball holder. So I've got some footage of this one coming up being printed. And you can see right where those are going to go. So stay tuned. I'm going to show you how I design these and how they're printed, and we'll put those in next. Software called Tinkercad to design this panel. This panel is actually designed by somebody else. It's available over on Thingiverse. So I'll link I'll put the link to that file down in the video description. But this is what we're going to use to modify this for our use. I don't need all of these cutouts and labels here. What I do need is the overall panel itself along with the locations for these 4 rivets. So if you've never designed anything in 3D software, basically what you're doing is combining a lot of different shapes together to get the end result here. You can see a cube, there's cylinder, sphere, prisms, things like that. So it's fairly basic to understand. You can get pretty complex shapes. Now I've already been messing with this, so I know the height that of this panel that I need here is 3 millimeters. You can see the edge is a little bit taller there. That's fine for what I'm doing. So I'm going to drag this over, and I'm just going to drag this to cover up everything. So we've got the text, we've got all the cutouts. We'll turn that solid, keep that same color. So I've got another block laid in with this one, and so all I'm going to do is select all of those, and I will combine those shapes. So now we have a solid blank panel. This is what I need. This is going to be attached to the golf cart, and then we'll draw out the hole for the radio from there. So this is going to save an STL file. So I'm going to export that, and then I will import that into a slicing program. So I'm going to pause the video real quick, and I'll move that over. Alright guys, so this is the slicer I use is Kira, made by Ultimaker. I've imported that file here, so we can see it here. We can zoom in on it, we can take a look at it, all that good stuff. I'm going to open the settings on here. If you're doing prototyping, one of the things you can actually do is change your infill. So I've got this thing 100%, so each layer that it prints, one on top of the other, will be completely solid. If you're doing some prototyping, you want to kind of be a little bit faster, you can change that. So I'll do 30%, and this is set to triangles. So if I slice this, and let me close that up, and I take this down a few layers, you can actually see as it's printing those middle layers there, it's not printing a full flat sheet of plastic there. It's only printing lines, which creates a honeycomb structure. That's actually fine for a lot of in-use cases. For the golf cart, I'm going to be doing just a solid piece. So I think this one's going to be good on first take, so I'm not too worried about doing a prototype on it. You can see those first few layers are solid. So we'll expand this out, change this to 100. The infill pattern at that point doesn't matter because we're not doing any sort of infill. Depending on what material you're printing, you're going to have to change your temperature settings. I'll probably have to change these on the printer itself, but that's fine. I'm using ABS plastic, so that prints higher. A lot of people, when they first start out, use PLA filament. It's a much lower temperature to print at, a little more forgiving. It's not as stable in heat, UV environments, things like that. So for the purpose of the golf cart, I need something that's stable, which is why we're using the ABS. There's a lot of other options that you can use in here to adjust your print as well. It's going to affect the quality and things like that. So we're going to go ahead and slice this up. And you can see this is going to be almost 9 hours to print this thing. So if I had concerns that this wasn't going to work the first time, which it may not, I may have to print another one, but that's fine. But I'm fairly confident this is going to work. So I'm going to go ahead and save this, and we'll move this over to the printer. But again, if you had concerns, you just want to get this thing out quick, you could change a lot of your settings. You can change that infill density, things like that. Use a filament that's going to print a little bit faster, and you can knock this out in just a couple of hours. Test it, make modifications, and then do your revisions to your final product. So I'm going to save this. We'll get this over to the printer and start printing. We're going to install this first one. First thing I need to address is these holes right here are smaller than the factory holes, so I'll just drill those out real quick. The other issue that we're running into, because we've crammed so much into this one panel, is this ignition switch is keeping us from actually mounting that. So that'll actually go in from the back once I get this thing in place. So I'm going to drill this out, we'll throw some rivets in, and then we'll get this ignition switch mounted up there. Alright, so we got the panel hooked up. We've got the USB charger plugged in. Got the 4-ways on. I pulled out the voltage meter. We still have to run wires for that, as well as the switch itself. So, but we can fish those up by hand later on. So we'll get that one in. Got our rivets. Right. We may not have the right attachment for the rivets. Got lost the other day. Yep, we gotta find that before we can do that. Alright, today's a new day, and got ourselves another rivet gun. So we can go ahead and pop this panel in finally. This first one. There we go, she's in. Next we'll knock out the other panel for the golf ball holder. Be right back. So this one's going to be done a little bit different. What we're going to do is hopefully, first of all, not ruin any plastic. I'm putting this epoxy in here. And the reason I'm putting epoxy here is because once this is riveted in place, we're actually going to drill a hole for the stereo. And once we do that, there's not going to be anything to support the center. So put that on there. Now, one thing I didn't notice, and I should look this sooner, there's actually no rivet holes here. The guy who that I copied this from, same guy who designed the original one of those, he had put, I guess, a piece of plywood or something in the back, and then he either put screws or rivets in there. So we may come back and hide those with something in the future. But this epoxy should hold this in place. That way, once we drill this hole out in the center, the edge of the edges of the panel there are going to be just flapping in the wind. So I'm just going to hold that. Hopefully that doesn't melt any plastic. So we'll just have to see. But I think it should be pretty safe. All right, guys, that's the finished product right there. You know, if you want to see what these look like once this build is done, be sure to follow the Project Marshmallow build. This thing started out as a white TXT. Like I said, we're gonna have the radio in there. We'll have a couple of other pieces here. So stay tuned.